What's going on, my ASVAB party people? Coach Anderson here, and welcome into our unit conversions class supercut. We have 2 recordings put together back to back, so you get a ton of practice, a ton of lesson. That way you can keep moving forward and raise that score. So why did I choose unit conversions? Long story short, my party people, y'all have been asking me, hey coach, can I get away with not knowing how to convert units? Can I get away with not knowing fractions? Short answer, no. No, not at all. The reason is because unit conversions is a skill that can be found in any topic. Topics like proportions, distance, rate, time, area and perimeter, volume, all of those topics, they can have unit conversions in them. So you have got to be ready to use that skill of converting units no matter what the problem is. And that's why this class recording is so awesome, because I'm gonna actually take you through every single one of those topics. Proportions, percentage questions, distance, rate, time, area, perimeter, all those geometry type questions. I'm gonna show you exactly how unit conversions can show up in any one of those topics. So go ahead, let's watch this recording. But before we begin, my party people, if you wanna join a free class, I host a free class once a week. So go ahead and check out the description of this video if you want to join a free class, typically on Mondays, 6 p.m. Eastern. And on top of that, I give you a free practice test with video solutions for arithmetic reasoning, math knowledge, word knowledge, and paragraph comprehension. I'm here to help you raise your score so you can get the job you want. So take advantage of someone trying to help you out. My party people, again, check the link out in the description so you can join our free classes. And we do have a full program if you're interested in that. But my party people, let's go ahead, let's move forward, and let's ace the ASVAB. Cheers. Yeah, again, just type ready. When you have an answer, just type ready. Don't reveal your answer until the time is up. Appreciate you guys. And looking at our final 3, 2, and 1. Go ahead, put those answers in, my party people. And if you have a guess, just put a question mark next to your answer if it's a guess. That way you're just letting me know that, hey, you know exactly how to get it done, but yay, there's my answer. Awesome. And also another point in terms of why I do the, hey, put a question mark next to your answer is because I want you to actually realize that point at which your confidence is really starting to come through for you. Because at first it might feel like you're taking more guesses than not. Then you're going to feel like you're actually putting down answers that you believe are right more often than not. Then you're going to see that you're actually getting these questions right. And you know that you're right before we even check it. So I want you to really see that kind of micro evolution for yourself. But there we go. That was question number one. We are going to move forward here to question number two. And then we'll come back and do both back to back. Here we go. 3, 2, and 1. And looking at our final 3, 2, and 1. Put those answers in. Put a question mark next to your answer if it is a guess. And no worries, take a guess. Even if you have no idea, go ahead, take a guess. You got this. Because remember, when all else fails, we can go ahead and take a guess on the actual thing. So let's go ahead and bring it back here to number one. Let's bring it back here. So my party people, especially those of us who've been, gone through this rodeo before, what's the first thing we always need to do? It's not going to be reading straight from right here. A construction worker needs to. No, we don't want to do that. We want to always start with what? Yeah, we always want to go straight to the question sentence. If you're looking at the chat box right now, you may see that it says RTQ, RTQ. Well, that stands for read the question. And I'm not saying read the question from the beginning like this. No, I'm saying read the question sentence right there. right there. So let's read that a little more clearly. That says, how long will each piece be? Okay, how long will each piece be? I don't know what that means entirely of the context, but I do know that I want to find out in some way, shape, or form that each piece equals something. And I look at the answer choices and we see feet and inches for most of them. So sounds good. So blank feet, inches. So my party people, before I even begin to, try to look at the information, is it clear to you that, hey, I'm looking for the length of some piece? And I know that might sound silly, right? I know that might sound silly, but the point of this is, hey, what do you know? Right? What do we know about the problem? Can we ease ourselves in? When you try to do too much and you try to, make a rocket ship out of a catapult, then things are just going to be a little messy, right? So take it slow. We're talking about pieces of something, and I just want to know how long each piece will be. So one of those pieces. Let's read through the information now to see what that means. So it says a construction worker needs to cut a steel beam that is 18 feet 6 inches long into 3 equal pieces. Okay, so we have the steel beam, 18 feet 6 inches long. So we can go ahead and say it's something like this, right? And we're trying to cut it into 3 equal pieces. My party people, when you kind of draw it out like that, does it make the math a little more obvious? Does it tell us exactly what we need to do here? You tell me, what does it sound like we need to do with the 18 feet 6 inches? What do we need to do? Yeah, we need to divide. We need to divide. We know that the entire beam from here all the way to over here, that's 18 feet 6 inches. But we know that this is going to be cut into 3 equal pieces. When we talk about cutting, especially into 3 equal pieces, well, we're dividing. We're dividing. Remember, the division is saying, hey, how many equal groups can we make? So my party people, before I even get to the division and the unit conversion that possibly might come with it, do we understand that this is for sure a division question? Sweet. And yeah, like it doesn't matter if you feel like you got this one right or wrong. Remember, the point is to always improve. So let's see what we can do. So again, it is division because we have the entire steel beam right here, this entire 18 feet 6 inches. And it says we need to cut it into 3 equal pieces. So that's why I cut it here and here to make 1, 2, and 3. And so it's division because we're cutting it up. We're dividing it into 3 equal pieces. So when we zoom on in and try to do the division here, so 18 feet 6 inches, and we want to divide this by 3, my party people, there are real 2 ways to go about this. Number 1 is going to be, hey, let's convert all of this into inches, divided by 3, and then convert it back if we need to, because it looks like the answers are in feet and inches. We could definitely do that, but I wanted to kind of just show you a nice little neat trick here that when you're trying to divide 18 feet 6 inches by 3, well, this is actually possible here because 18 is divisible by 3 and 6 is divisible by 3. And so because they're both divisible by 3, nice and clean, we can actually go ahead and divide each by 3 and be done. My party people, what's 18 feet divided by 3? 18 feet divided by 3, that's going to be 6 feet. And then 6 inches divided by 3, what's that going to be, everybody? 2 inches. So there's our answer. 6 feet and 2 inches. So that would be answer choice A. But I want to make sure I satisfy the masses here. In case anybody here is a little untrusting, does anybody here want me to actually do this the normal way, turn all of this into inches, then divide by 3, then bring it back? Who would want me to do it that way too? Yeah, I got y'all. I got y'all. Again, I'm not going to sit here and try to race through. Like, I'm here for y'all, not the other way around. So let's go ahead and do it that way. But this is going to bring up the conversation of how do we turn 18 feet into inches, right? How do we do that? So allow me to just move this over to the side, over here, and I'm going to grab this, duplicate it over here, and then make this just a little smaller. Okay, so let's go ahead and do this now. Yeah, the key word for division was going to be cut into 3 equal pieces. So yeah, let's go ahead and convert 18 feet first. So remember, my particle of the conversion is 1 foot equals 12 inches. So if we're trying to turn 18 feet into inches, notice that, look, if we go from 1 foot to inches, you times by 12, you multiply by 12. So that's what I'll do here. Everybody, do you agree? To turn 18 feet into inches, we will multiply by 12. Yep, 1 foot is 12 inches. And that's because for every foot that you have 12 inches that make it up. So when you convert, you're breaking up the 1 foot into those 12 inches, into the 12 pieces. So yeah, once we do this here, here's what we're going to have. 8 times 2 will be 16. 1 times 2 is 2. Carry the 1 is 3. Then we have 8 times 1 is 8. 1 times 1 is 1. Add this together, and we end up getting right there, then 11, and then 2. So we have 216 inches right here. And then we still had the 6 inches from before. So my party people, how many total inches do we have now? We had 216, and now we have 6. So together now we have what? What do we get? Yep, that'll be 222. 222. 216 plus 6 inches would be 222. All right, so there we go. And we're still going to be dividing by 3. We're still dividing by 3. So we just keep rewriting it right there and there. All right, now let's go ahead and divide. So when we divide that by 3, let's go ahead and make this just a little smaller over here. Perfect. And then we'll bring this right back and we'll do the division. So 3 into 222. That's right. The last version was a little easier if you knew how to do it exactly. So 3 goes into 22. That'll be 7 times minus 21. Bring that 2 down. 3 goes into 12. That'll be 4 times. Okay, great. Perfect. There we are. And so we have 74 inches. Who knows how to convert inches back into feet and inches? Who knows how to do that? What do we do? Yeah, we need to divide by 12. We still need to convert it back into feet and inches. So that's what makes this a little annoying, right? That's what makes this just a little annoying, but we can still do it. And so remember, when we convert back, we are going to do 12 inches. How many times can 12 inches, or how many groups of 12 inches can we make with 74? And here's how. My party people, 12 goes to 74 how many times? Yep, that's going to be 6 times. So that's going to mean that this right here is 6 feet. That's 6 feet. And we know that 6 times 12 is going to be 72. So that's going to be 2 left over. My party people, the 2 represents what? Since the 2 is the remainder, and we're trying to see how many groups of 12 inches we can make, 2 is the remaining number of, 2 is the remaining number of inches. So we end up having a final answer here of 6 feet 2 inches. My party people, is that what we're looking at? Oh, yes. Oh, yes. That is that final answer right there. So my party people, do you think that something like this might be useful when I pointed it out earlier, when we knew that we were dividing and we saw that both the feet and the inches could be divided by 3? So we didn't have to go through all of that craziness, all of the converting, then dividing, then converting back, right? If we can notice an easier way to do it, we should definitely take advantage of it. But you can't get to that point unless you know when you're in that position. So you have to practice. Exactly. The only way you can save time on the test is by putting in the work beforehand. It's the only way. But that is the first question by part of people. Are we feeling better, the same, or worse than we did when we tried it out? Right on, my party people. That's good. Glad to hear it. All right, so here we go, my party people. Let's go ahead and take a look at the second question. So the second question here, what do we have? So the second question here, we are asking for what is the area of the room in square inches? Okay, so my party people, what is the concept that we are doing in this question? What is the concept that we are working on? Yeah, Adrian, keeping it easy. Appreciate you. Yeah, that's going to be area. We're trying to find the area of some shape, right? We're trying to find the area. And yep, those of you who have been to my classes before on pure geometry or pure award problems that involve area and perimeter, whenever you say area or perimeter or volume, we want to know what shape. If we don't know what shape, how do we know what formula to use? So I know that I'm looking for the area, and that's going to be the area of a rectangle. Booyah, right there. So with that said, we are looking for the area of a rectangle. And my party people, can you remind me, what's the formula for the area of a rectangle? Matthew already got it in there. Perfect. Yeah, area equals the length multiplied by the width. Right on. All right, so now that we have that going on, let's go ahead and figure out what the length and width are going to be. But we have a little caveat in the problem, my party people. They have us find the area in what units? What units are we trying to use? Right. They want us to find this in square inches. Notice how it doesn't say square feet. So some of us might be looking at this thinking, oh, yeah, we'll just take the area by taking the length, which they give us right here. You might be tempted to write 12 feet, 6 inches, multiplied by, and then you see over here that it says something to the effect of, let me use purple. It says 9 feet, 3 inches. So you're going to write times 9 feet, 3. But the problem is, my party people, well, if you just try to multiply whatever this is, first of all, it doesn't really make too much sense to multiply it like this. But number two, you're told that you want your answer in square inches. Because you want the answer in square inches, everybody, does it make sense that we should first take this, turn that into inches, take this, turn that into inches, and then multiply? Sweet. So y'all get it. And this is where I'm going to re-emphasize the point, my party people. Do you see already in just this second problem, we can have a problem that's not entirely unit conversion. It's an area of a rectangle problem that just so happens to need you to convert units before you calculate. You see what I'm talking about now, everybody? Perfect. Like this is what I want you to prepare for. Unit conversions, decimals, fractions, they're just numbers. They can be part of any problem. So here we go. 12 feet, 6 inches. Let's turn that over. So my length, 12 feet, 6 inches. Everybody, what do we do to every foot to get that into inches? What do we do? We take every foot and multiply it by what? Yeah, multiply by 12. So we'll multiply this right here times 12. Everybody, 12 times 12 is, yep, 144. So we have 144 inches there. We still have the 6 inches from before. So this makes a total length of what? Makes a total length of 100 150 inches. Right there. So we have this 150 inches. We're not done yet, though. We have to figure out what 9 feet 3 inches is in just inches. So we'll take that width right over here. And we have 9 feet 3 inches. All right. So my party people, like we said before, we'll just go ahead and multiply every foot we have by 12. And then from there, that's going to be 108 inches. We add that with the 3 inches we have there. What's that going to be, everybody? Yep, 111. All right. So there we are. We took that little detour, right? We had to go ahead and turn the length and the width into just inches. Boom, we did that. And so now we have to go ahead and actually multiply these two dimensions together. And then we are going to be done. So if I go ahead and set this up right over here, 150 multiplied by 111. Well, remember, everybody, when you're multiplying, we're just going to go ahead and go each digit at a time. So we're going to go ahead and do 0 times 1, 5 times 1, 1 times 1. Then next row times 1, next row, all times 1. So if you look at this, this is not that crazy. This is not that difficult. I'll show you right here. So if I just go ahead and highlight each color by place value, here's what we have. 0 times 1, 5 times 1, 1 times 1. I'll put the 0 in for the next row, and then I'll go ahead and show you this one here. All right, 0 times 1, 5 times 1, 1 times 1. And then here, the last one, we have 0. Let me go ahead and put the 2 zeros here to make sure we're good. And then we have 0 times 1, 5 times 1, 1 times 1. So look at that. It's not going to be as difficult as we thought it was going to be. And we have 0, 5, 6, 6, 1. And there's our answer. Our area equals 16,650 square inches. And there we go, my party people. Boom. So notice the math that we did here, it's pretty doable. You know, we know how to multiply by 12. We know how to multiply by 12. We know how to multiply by bigger digit numbers. But in a word problem, you have to be prepared to go ahead and do all of that in the right order and still do it correctly. So how are we feeling about this second one, everybody? Again, better, the same, or worse than before? And again, be honest, be honest. Because remember, I'm here to pick up on how you guys are feeling, and I'll adjust in little small ways here and there to make sure that I continue pushing you in the right direction. So cool. In the first question, remember what we did was, well, it's just a regular division question. Imagine if the question said, hey, we have this 18-foot steel beam. Forget about the 6 inches. If it was an 18-foot beam and you want to cut it into 3 pieces, well, that's just 18 divided by 3. If we're over here in the second question, it says, hey, what's the area of the rectangle? Okay, length times width. It just so happened that we had to convert beforehand, but we knew what we were supposed to do. It just so happened that we had to convert in the middle of it. So we have to really think about those cases. That's right. So my party people, are you ready for the next set of questions? I think we're good to go to 3 questions back to back. How do you guys feel? You ready for 3 back to back? All right, let's do it. Sounds good. So let's go ahead, and no worries, Ryan. We're going to go ahead and do this next one 3 back to back, but then we will continue. We should have only enough time to do one at a time after that one. So really remember, guys, the point here is get that practice test feeling, get used to it and learn to work with it. So let's go ahead and take a look at these 3 back to back. Do your best on the first. Forget about that first and go on to the second. Forget about that second, get into the third. So let me put that timer right here for you. And let's go ahead and go. 3, 2, 1. Here's the first of 3. And remember, my party people, go ahead and put ready when you're ready, and then we'll reveal the answers when the time is up. And looking at our final 2, 1, and time. My party people, go ahead, put those answers in. Put those answers in. And again, put a question mark next to those answers if it is a guess, if you feel like it's a guess. And yeah, remember, don't give up on the process. Not at all. Not this early. Don't worry. I promise you, by the end of the class, we'll all be feeling at least, again, one step ahead of where we were. All right. So again, short-term memory. Let's move on to the next one here. This is 2 out of 3. And again, after these 3, we are going to go ahead and just do 1 at a time for the remainder of class. 3, 2, and 1. All right, and looking at our final five, four, three, two, and one. Go ahead, put those answers in, my party. We'll put those answers in. Put a question mark next to your answer if it is a guess. And again, regardless if this is your first or 50th class, remember, we're just here to try our best. And then as we go through the solutions, I want you to understand that there are two pieces to the pie. Number one, hey, can we figure out what we're supposed to do? And then number two, can we actually do it? And what I'm referring to is number one, can we turn the English into the math, like into the concept, into the idea? And then number two, okay, once we have the idea laid out, can we actually calculate and do the actual math? So let's go ahead. We have one more to go. Number three coming up here. Timer is getting reset in 3, 2, and 1. Let's go. Final five, four, three, two, and one. So that was the third of three questions. Go ahead, put those answers in. What do we have? What do we have? How much does that small wrench weigh in ounces? Go ahead. Go ahead. What do we have? What do we have? All right. All right. So this is about the midway point in the class, and I want to ask everybody, are we seeing our ability to kind of, hey, let me forget about the math for a second. Can I see what the English means? Like, is anybody here feeling like, oh, with this specific question, they understood that it was a proportion question? Who here understood that this one was a proportion? I'm not asking you if you knew how to do it correctly. I'm just asking, were you at least able to recognize that, oh, the word ratio, and we're comparing the same things in the same way? A large wrench, small wrench. Here's the large wrench. How much is the small wrench? Do we start noticing those patterns in the English to help us. Hey, this is a proportion question. Okay, let me think about how to set it up, but I at least know that this is a proportion question. Yeah, so Priscilla, you're good. If even a kind of is there, that's good. That is a good thing. Now, how about with the second one, my party people? Who here, was able to ignore again the unit conversions? We don't care about the numbers until we know what they mean. So who here was able to look at this one and focus on this? That we're looking for the mean, the average, add them all up, divide by the number of numbers. Who was able to recognize that? Good. Again, even if you were able to just recognize the actual concept that we're dealing with, because the actual concept is not unit conversions. It is not. The actual concept here was mean. Unit conversion is just going to be part of the process. It's just going to be part of the process. Now, let's take a look at the first one. And this is the one that we're going to start by solving. So who here realized that, no, this is not a unit conversion question? Who here realized that this is a distance, rate, time question? Who realized that? There we go. So that's what I'm talking about, everybody. I definitely see some of us who are absolutely nervous in the beginning starting to understand that, look, it's not a flip of a switch. It is not that. It's a series of small understandings. And then as we continue to ramp things up, you get more of those little checks understood. That's really all it is. So we have to start small, even if we don't know what the correct answer is. We've got to be willing to say, hey, this is what I know about it. This is what I don't know about it. And you keep working to build those connections. So here we go, my party people. What is it that we're looking for in a word or a short phrase? What are we looking for? And you can give me a full sentence too, but make it make sense to me. What are we looking for in this question? That's the first thing we focus on. Nothing else. Okay, so Ryan, you say how many miles? But let's be a little more specific there. Yeah, there we go. How many miles in 12 minutes? So right over here. How many miles will the rocket travel in 12 minutes? So my party people, is it fair to say, yeah, I see you right there. Who is that? Let me just see your name. Laura, I see you noticing that, yeah, this is a distance that we're looking for. How many miles? So we're looking for the distance, what that's equal to in miles, when the time is 12 minutes. So take a look, my party people. We have our formula. Distance equals rate times time. Who recognizes this right here? Distance equals rate times time. Right on. So if you don't recognize it, no worries at all. No worries at all. So for those of you in the program, let me just call this out for you. This is going to be arithmetic reasoning, unit number 5. That is where distance, rate, time is in. So if you want to go ahead after this class tomorrow morning, whenever you want to, and you want to focus on just distance, rate, time, boom, that's where you'll find it. And I'll do that for the remainder of the problems in today's class. So let's go ahead and get number 1 going, my party people. So here again, we're looking for the distance in miles after 12 minutes. If you look at the information you're given, you might notice one more thing here that says a constant speed of 18,000 miles per hour. So that's going to count as the rate. Rate equals 18,000 miles per hour. All right. So here's the next question I'm going to ask you. Why is it that we can't just throw in D, then put the 12 for T, then put 18,000 for the rate? Why can't we do that? Through my pencil accidentally. But why can't we do that? Right, it's not the same thing. We're not representing the terms in the same way. What does that mean, coach? Easy. Think about it like this. The rate says 18,000 miles. Okay, distance is in miles per hour. My time is in minutes. That's not good. That's no good at all. Yeah, the distance is in the same units, the miles and miles, but the time is not miles and hours or minutes and hours, excuse me. So that's no good. We have to be consistent with the units. Yes or no, my party people, did you understand that? We have to be consistent with the units. Awesome. Sounds good. So if we want to be consistent with the units, we can go either way. We can try to convert miles per hour to miles per minute, which is a little harder than you might think if in terms of conceptualizing it. Or we can turn the minutes into hours. Sure, we might have a fraction or a decimal, but it doesn't matter. 12 minutes turning into hours, we can do that. So let's go ahead and turn this right here. Let me just put a little asterisk here. Turn this into hours first. My party, but does that make sense? We have to convert this first, and then we're good. All right, great. Sounds good. Here we go. So, my party people, how many minutes are in an hour? Help me out with the conversion here. I'm gonna move this all the way down here. My time is equal to 12 minutes. How do I turn minutes into hours? Okay, yep. So 1 hour. Let me write this in green. 1 hour equals 60 minutes. I'm going to show you a way of converting that for those of you who have been to the class that was about a month ago. I think you guys really enjoyed this one. Let me just go ahead and show you. Nice and easy. So here, I'm going to say that we have 12 minutes. And I'm going to multiply by what's called a conversion rate. All this is just a fancy way of saying, go ahead and throw these two numbers here in a fraction. Throw them in here. My party people, we're trying to get rid of minutes and then just leave hours, right? We're trying to get rid of minutes, leave hours. Yes or no? Yeah, we're trying to get rid of minutes and just leave hours. So watch what I'm going to do here. I'm going to put the 60 minutes right down here and put the 1 hour right up here. This is what's called a conversion rate, okay? This is what's called a conversion rate. This is like the surefire way, conversion rate. So this is the surefire way to get rid of old units and then leave the unit that you want. Because guess what, everybody? 1 hour divided by 60 minutes, that's just one. All we're doing here is converting. We're not changing the value. We're converting the value because 1 hour is the same as 60 minutes. Technically, we just cancel this out if we wanted to. Or we could notice that, hey, I am actually going to be canceling minutes because you have minutes up top, minutes on the bottom. So that gets canceled out. So that's how you know where to put which. That's how you know if you're supposed to be multiplying or dividing by that number. Here it's going to be division because you have 60 on the bottom, 12 times 1 up top. So it's going to be 12 over 60. That's what this is. My party people, does that make a little more sense? We get rid of the old unit by putting it on the bottom or away from that current unit, and then put the new unit you want up top. It's all about cancellation. That's all that demonstration was. Sweet. So again, I go over this a lot more in the recordings of previous classes and in non-practice test classes, but here we go. We have 12 divided by 60. So we can do that if we want to, or we can just go ahead and divide 60 into 12 to get the decimal. Let's go ahead and do that. My party people, 60 doesn't go into 12, but it can go into 120. That would be what? 60 goes into 120. That's going to be 2 times right there. That's going to be 2 times. So 12 over 60 hours is the same as 0.2 hours, which is the same thing as saying a fifth of an hour. 12 minutes is a fifth of an hour. We could have said that with practice, but I wanted to show everybody here. So once we have that, guess what? We're going to take that 0.2 hours. That's going to be the time right over here. And now we're good. Now we'll replace, again, distance equals rate times time. We'll do the distance, leave it like that because that's what we're looking for. 18,000 miles per hour times 0.2 hours. And we're good. So from here, we'll go ahead and show 18,000 multiplied by 0.2. So we'll have 0 0, 0. 8 times 2 is 16. And then 1 times 2 is 2, carry the 1 is 3. And since we had one decimal place here, we will need to bring one decimal back. So 3,600 miles. And there we are. So yeah, even if you took a guess and you got it right, again, pat yourself on the back real quick. But what we want to do is make sure that we understand that process from start to finish. But there it is. That's going to be answer choice B, 3,600 miles. Yeah, there's nothing wrong with guessing on the ASVAB, and that's why I'll never chew anybody out for guessing in the class because, hey, that's a test-taking strategy. You're good. But it's always better to know exactly how to do it straight up. And yeah, you can absolutely do it the other way by turning the miles per hour into miles per minute. To go from miles per hour to miles per minute, you divide by what's going to be 60. And then once you're there, which would end up being something to the effect of 300, then you would do 300 times 12, which would give you 3,600. So yeah, it would definitely still work the same exact way. You're good. But again, that one's going to be Arithmetic Reasoning, Unit 5. So my party people, are we good? You see how you got the wrong answer there? Good, I'm glad. And again, the next step is the next time you see a unit conversion question, again, just exemplify that confidence just a little more. So are we ready to move forward to check out the next question? Right on. So here we go. My party people, here's the next one. I highlighted what we're actually doing. It is finding the average or the mean. Can anybody describe to me in a phrase or a sentence, how do we find the average again? How do we find the mean? That's right. Add them all up and then divide by the number of numbers that you added. So here, notice that we have 1, 2, 3, 4 numbers. So remember that when we are calculating average, we are going to find the total, and then you're going to divide by the number of numbers that you added up. So in this case, everybody, we are going to be dividing by 4. In this case, we are dividing by 4. So boom, right here. Sweet. And now, next thing we're going to do is add everything up. So let's go ahead and take care of all of this over here. 5 feet, 7 inches, 8 feet, 4 inches, 2 feet, 11 inches, 12 feet, 6 inches. We have to add all of that up. So let's go ahead and do it one by one here. We got no time to waste. Let's get the work done. So let me move this over. Perfect. All right. So everybody, when we look at 5 feet, 6 inches, help me out here, my party people. 5 feet is what? 5 feet is how many inches? Yep, 5 feet is going to be 60 inches. Remember, when we multiply the 5 feet by 12 inches per foot, we are going to get 60 inches. And then we add that with the 7 inches that was already there. And that's going to get us 67 inches. Are we good there before I continue? Yes or no? Perfect. Let's go to the next one here. So this is the first one. Let's go to the next one. I'll put this right here. So we have 8 feet, 4 inches. So 8 feet, everybody, multiplied by 12 is going to be what? Yep, that's going to be 96. And then we'll add that with the 4 inches that was already there. And that's going to give us 100 inches. Sounds good. Notice that we have to stay calm, cool, and collected, everybody. Just got to stay calm, cool, and collected. Next up, here we go. So now we have 2 feet, 11 inches. So we have 2 feet multiplied by 12. And that's going to be 24 inches. And then we are going to add the 11 inches that was already there. And that's going to give us 35 inches. And then lastly, we have the 12 feet, 6 inches. Here we go. We'll go ahead and have the 12 feet that was already there. We'll multiply that by 12 because it's, again, 12 inches per foot. So that's going to be 144 inches. And we're going to add that with the 6 inches that was already there. So 144 plus 6, that's going to give us 150 inches. And there we are. So we have everything that we need to add up together. My party people, did you get the same numbers as you were converting? 67 inches, 100 inches, 35 inches, and 150. Did we get those? All right, so let's see if that's going to be 352 in total. Let's see. So now we'll go ahead and add them all up. So we can just add the easy ones first. So we can say 100 plus 150, 250. 250 plus 60 is 310, 340, 347, 352. So the total is 352. Boom. So we're set. We're good. We can move forward now. We can go ahead and put that right there. And notice, again, the unit conversion was just part of the problem. We are doing an average or a mean problem. So here we are, divide by 4, and we're done. So 4 going into 352. 3 goes into 35, or 4 goes into 35, excuse me. That'll be 8 times. Subtract the 32, giving us 3 left over. And then 4 goes into 32, exactly 8 times. So there's our average. Booyah, we're done. And there it is, 88 inches on average for the length of the 4 pipes. But we're not done, everybody. What do we have left to do? Yeah, we got to convert it back, right? So this is what I'm saying. Like, if you've practiced this enough, this whole process of converting all of this, then adding it all up, that could have been done very, very quickly. If you've gone through the math basics, if you're in the program and you've gone through the math basics, this is going to be like 30 seconds of the process, then here another 10 seconds, and then a quick 5 seconds in your head to convert it back. To convert back, we'll just go ahead and divide exactly 12 inches into 88 inches to see how many groups of 12 we can make. 12 goes into 88. That's going to be 7 times because it's going to give us 84 with 4 left over. So we have 7 feet with 4 remaining inches. So that's 7 feet, 4 inches. Yeah, this would be heavy points because it's more than just a simple problem. It's more than just a quick calculation. You have to understand how to navigate everything that you have in front of you between the unit conversions, finding the average, and then working with larger numbers. And so, Thomas, no, to answer your question, do you have to show your work for each of the questions? No, you don't. No, you don't. Absolutely not. The ASVAB is graded based off of how well you do compared to other people, and they just judge whether you got a question correct or incorrect. Some questions are worth more because there are more steps or it's a higher order of difficulty. But long story short, your job is to get as many questions correct as possible, and that's why I don't really say anything about taking guesses. You know, there's a good thing about them. Ronnie, I'm glad you know how to solve this problem now. So, quick question for everybody here. Are we feeling better, the same, or worse about this one? Yeah, I'm glad. I love the excitement. I love the excitement. That's good to hear. Right on. Yeah, you can absolutely do it with practice because the question was simply just about finding the average, which is right here. This is everything you needed to write down. If you like, this is just actual work. This is actual work. This is actual work. This was the concept, finding the average of the numbers. That was the concept. And so just to go over what this does for those of you watching the recording at this time, all we needed to do was find the total number of inches and divide by 4 because we have 4 things being added together. We converted each of these into inches, added them together to get the total inches, and there it is. We divided by 4 to get the average, and there we go. But the reason that we divided by 12 was because 88 inches is not here. It's not listed. So we need to convert this back into feet and inches, and that's where the division of 12 happened. 12 goes into 88. How many groups of 12 or 1 foot can we make? 7 of those with 4 inches left over. So one more time, are we good to move on to the next one, my party people? Are we good? All right, sweet. Let's go ahead and get into number 17. So this is the proportion one. So notice I've been telling you guys, it doesn't matter. We can have unit conversions in any topic, any topic. So let's get into this one. Proportions. You hate proportions, Ronnie? No worries. And Roby, I think you're in the program. Watch the recording first thing. And I think I may be posting this one this week to YouTube. So let's go ahead and get into this one, everybody. Give me a short phrase or sentence. What's the goal overall of this question? Don't say proportion. Tell me what we're trying to get. What's the goal? What do we want? What is it that we want in context? This story, what do we want to end up with? The right answer. I love you, trolls. But yeah, so the second answer that I'll take, aside from the obvious one, is the weight of the small wrench. And yeah, they give us a little more specificity there and say, yeah, we want it in ounces. But yeah, if you were to say at the very least, we want the weight of the small wrench, that's good. And we want it in ounces, so we'll say small wrench equals blank ounces. So when we read through, this is how we discover that we're dealing with a proportion question. Read it here. It says the weight ratio of a large wrench to a small wrench is 5:2. If the large wrench weighs 2 pounds, 8 ounces, how much does the small wrench weigh in ounces? My party people, help me out. What's that main idea? Because remember, every concept has a main idea. What's the main idea for discovering proportions? What's the main idea to know that you're dealing with a proportion? I'm going to write it down. First person to write it down, what do we have? Adrian, yes, that is correct. Compare the same things in the same way. V, appreciate you there. We know that this is a proportion when, again, we are comparing the same things in the same way. So write this down here. Again, this is for proportions. Just move this over here. The main idea is, again, compare the same things in the same way. And there we go. Yeah, so Ramos, I got you. I got you. So write that down, everybody, especially for those of you who have not seen me go through a proportions class before. Right there, compare the same things in the same way. That's what we want. Nope, I'm going to show you exactly what to do. I got you. So let's write down the information here. It says that the ratio of the weights of the large wrench to small wrench is 5:2. So let me write this over here. I'm going to write the 5:2. And again, that's the ratio of the weights of the large to the small. That's the ratio, 5:2. Now, what else did they give us? Well, they told us that the large wrench weighs 2 pounds, 8 ounces. So it says right over here, large wrench, we'll write 2 pounds, 8 ounces. And we're going to compare that over here to whatever pounds and ounces it is. But my party people, before I continue, do you notice that on the left side, I'm comparing the large wrench to the right side, small wrench. Over here, left side, the weight of the large wrench. Over here belongs the weight of the small wrench. Do we see how we're setting it up to compare the same things in the same way? You're comparing the ratio of large to small and then the weight from large to small. That's what a proportion really is. Just comparing the same things in the same way. Now, there's going to be a little bit of an issue where we're going to need this right here in just ounces. I'm going to need this in just ounces. Because if we're trying to solve a proportion, you need to have it consistent. So here, let's turn that over here. We have 2 pounds, 8 ounces. My party people, help me out. How many ounces are in 1 pound? That's correct. 1 pound equals 16 ounces. So I'll write that right over there. So yeah, what we'll do is we'll multiply the 2 pounds times 16, and 2 times 16, that's going to give us 32 ounces. And then we still have the 8 ounces left over. So everybody, we add this all up and we get what? Yep, that's going to be 40 ounces. So what we'll do is we'll actually just take this and we'll put it down here, but we'll just say 40 ounces right there. Boom. So now we'll be able to solve this in the right way to keep the answer in ounces. Because again, if this side is in ounces, then this would be in ounces. It's the same unit. So here's how we set up a proportion. I'll just go ahead and use X for the answer. And so all I'll do is just compare the same things in the same way. Large to small. So let me use a different color here. So large to small, 5/2 equals, again, large to small, 40/X. It's that simple. It's that simple. Compare the same things in the same way. Large to small, large to small. So now, everybody, help me out. What are we taught to do when we're trying to solve proportions? What's the main way we're taught? Well, Ryan, if you're talking about the main ways my classes, then yeah, we reduce it first whenever we can. But typically, when you learn this before in high school, typically we do what? We start by, we start by cross multiplying, and then we would do what? And then divide. So I wouldn't say that a ratio is division, Thomas. A ratio is basically saying a ratio is a fraction. So yes, you could divide the top by the bottom, but that's not necessarily the point. The point of a ratio is to just declare a comparison. So when we say the ratio of large to small, we're just comparing their sizes. If the large one is 5, the small one would be considered a 2. So you're just comparing their values. And how that helps us is, hey, when we set up a proportion, we have a ratio on this side and a ratio on this side. But the reason that a proportion works is because this ratio and this ratio are the same comparison. From large to small, the size difference is the same from large to small in reality. And now that we're here to actually solve this, we cross multiply and divide. So here, 5 times x, that's 5x. And then 2 times 40, that'll be 80. So that's the cross multiplication part. And now we're going to go ahead and divide both sides by 5. Once we do that, divide by 5, it's going to cancel out on the left side. And then here we have 5 going into 80. 5 goes into 8 once. And then 5 goes into 30 6 times. So the final answer will end up being X, or the small gear, the small wrench, will be 16 ounces. And there we are. Boom. Answer choice here is B. So don't worry. If you were here and you understood, hey, yeah, pounds to ounces over here, I know how to do that. But coach, I didn't know how to do this setup here. Don't worry at all. For those of you who are curious, again, in the program Arithmetic Reasoning Unit 2, that is all proportions. In this question, we're mixing proportions and unit conversions. So I can definitely see how this can be frustrating. Absolutely. But I have to do due diligence here and really show you what you should be expecting. So my party people, after the next 3 questions here, where we did a distance rate time question with a unit conversion, we did an average question with unit conversion, and then we did a proportion question with unit conversions. How are we feeling about understanding the difference between a concept and a skill? Are we feeling a little better about knowing that unit conversion is a skill that we should be prepared to use? Because that's really the biggest question to me. Like, that's the biggest thing I want you guys to understand. Unit conversions are a skill. Dealing with decimals, that's a skill. Fractions, that's a skill. Negative numbers, a skill. We have got to know that those are skills, and there are concepts like proportions, distance, rate, time, area, perimeter, average, and all that. All right, so yeah, I got you. If you need to take a screenshot, go ahead. And no worries if you're lost. I got you. Because again, I'm going to post the recording tomorrow. So number one, there, I got you. And then number two, for those of you again in the program, make sure you go through the math basics first, because these are upper level questions. Today's class, typically I would go ahead and keep it, just single topic. But today you guys were asking me, hey coach, can we do a couple more, challenging questions? You asked for it. This is that day. I got you. All right, so here we go. Let's go ahead and get into the next question. We're going to go one by one all the way. And then I'm also going to give you the topic if there is a specific topic of it. So with that, everybody, let's go ahead and get into the next one here. In 3, 2, and 1. Again, we're doing this one at a time here. And in this question, I'll give you the topic. I'll write it on the side. This is arithmetic reasoning, unit number 8, for those of you interested, and the perimeter formula. And there you go. Try your best here. And there is your timer. And that is time. My party people, go ahead, put those answers in, put a question mark next to your answer if it is a guess. All right, right on. So let's go ahead and tackle this one. That looks like a lot of us are excited about this one. So here we go. So first things first, everybody, again, read the question and tell me exactly what we're looking for. What is it that we're looking for in a phrase or a sentence? Right. Looking for the perimeter of the park in inches. So what we have here is, again, perimeter of the park in inches. And we see that it's a square park. That's why I gave you this formula here. The formula here represents the perimeter of a square, and all we need to do is do 4 multiplied by that side. Nice and easy. So again, just to show you a nice little square here. So here's a square. And the reason it's 4 times the side is because we have side 1, 2, 3, and 4. And all the sides are the same. So that's where that comes from. So I'll move that right over here, and then I'll keep putting in this work. So the next thing that we're going to do is, well, okay, take the side, multiply by 4. Let's do it. Take the side, multiply by 4. So we'll do 4 times 25 feet, 8 inches. Got to multiply all that by 4. Okay, sounds good. No problem at all. There are, excuse me, there are really 2 ways we can do this. Number 1, I'm going to show you the long way, and then I'll show you a nice shorter way in a moment. So the longer way is going to be, hey, let's go ahead and turn 25 feet into inches, and then add that with the 8 inches that exists. Who did that first? Who went ahead and turned the 25 feet, 8 inches into just inches before you multiplied by 4? You? Okay, cool. Sounds good. So that's what's expected. So let's go ahead and take care of that. So we are going to remember that 1 foot equals 12 inches. And so that's what we'll do. We'll multiply by 12. 25 times 12, what will that be? Let's go ahead and just write that over here. 5 times 2 is 10. 2 times 2 is 4. Carry the 1 is 5. Then we have the 0 there. 5 times 1. 2 times 1. And that's going to give us 300. Sweet. So we have 300 inches plus the 8 inches. And that'll give us 308 inches. So we have 4 times 308. And so once we do that, okay, sounds good. 308 multiplied by 4. 8 times 4 is 32. 0 times 4 plus 3. 3 times 4 is 12. And we have 1,232 inches. Boom. And there we go. The 4 comes from having 4 sides that are all the same. Remember, perimeter is the distance around. So the distance going all the way around, that's where the 4 comes from, because we have 1, 2, 3, and 4. But with that said, there we are. The other way that we could have gotten the answer here, everybody, is just by going ahead and saying, hey, 4 times 25 feet, 8 inches. Let me get this out of the way. We have 25 feet, 8 inches. Well, we can actually just go ahead and multiply by 4, and that would be 100 feet, 32 inches. And then when we want to turn the 100 feet into inches, I realize that 4 times 25 is 100, making this a really convenient math. 100 feet to turn into inches times 12. That's going to be 1,200 plus the 32 inches that was already there. And that's going to be the same answer. 1232, and we're good. So we could have done it either way. And yeah, just wanted to show you that you could have done it more than one way. And you could have saved a little more time, but not that much time, because either way, the math was straightforward. Answer is D. Lawrence, glad you had a light bulb moment. That looks awesome. Everybody else, how are we feeling? Better, worse, or the same? Right on. It looks like we should have enough time for at least 2 more questions. Hopefully we'll try to squeeze out a third, but we definitely have time for the first 2. And again, don't forget, for those of you in the program, tomorrow's class is a follow-up on this one. Brand new questions again. And as always, you'll get access to all of the questions that we would have done in a nice little practice test, and you can see the recordings attached to them. I got y'all. So here we are. Let's go ahead and get ready for the next one. Let me get the timer up right here. All right, here we go, my party people. 3, 2, and 1. And looking at our final 4, 3, 2, and 1. Put those answers in, my party people. Go ahead, go ahead. All right, yeah. Put a question mark next to the answer if it's a guess. No worries at all. No worries at all, my party people. So let me go ahead and get that timer out of the way. Let's go. Let's try this one out. So, first things first, as always, we have to read the question. We have to understand what it is that we're trying to find. So, my party people, in a word or a phrase, be concise. What is it that we want to find here? Angelique, yes. Thanks for being specific there. How many whole pieces can the worker cut from the boards? Again, how many whole pieces can we cut from the board? So we have to be specific here because, we don't want to round. We need entire whole numbers. We cannot round what we have, what we get. So let's understand the situation a little bit and follow along. It's all good. We want to know how many whole pieces can we cut. We see that it says a construction worker needs to cut some wooden boards for a project. The total length of wood that needs to be cut is 14 feet 7 inches. So again, we have all this, all that. This is going to be again 14 feet 7 inches. Okay, cool. So from here all the way to there, and then all the way over here. And what we're trying to do is each piece here that we're cutting is 1'11" long. So we're trying to see how many 1'11" pieces we can cut. My party people, what are we going to do with the 14 feet 7 inches and the 1'11"? What are we doing? What are we doing? What's the overall process or concept here? What are we doing overall? No, conversion is part of the process. Conversion is part of the process. But what concept are we dealing with here? So forget about the unit conversion. Let's say, hey, this is just 14 feet. Not, forget the 7 inches. Let's say it's 14. If this is 14 and each piece is 2 feet, what do we? Yeah, exactly. Now we get it. That's division. That's division. Just because we have fractions here, don't let that take you away from what we're actually doing here. The conversion is part of the process, but we are truly dividing. Hey, no worries, Dimitri. Hey, you're trying your best here. And I love seeing that because we may be saying my bad now, but then next week it's, oh, I knew that. Week after that, it'll be, man, I'm getting really good at this. So, we always want to celebrate those successes. You got this. So the reason why are there only 4 squares you pieced out? Or, I mean, we can continue going. So that's the point. The point is, how many of these can we fit in? And the way that we'll find that is by dividing. So that's the overall goal. The overall goal is to do 14 feet 7 inches divided by 1'11". But of course, as you guys pointed out, we definitely need to convert this before we divide so we can get this done the right way. So I noticed that the bottom part is a little easier for me, at least. So 1 foot, that's going to be 12 inches plus that 11 inches that's already there. So that'll be, my party people, 23 inches. Yes or no? Are we good with that first conversion? 1 foot, 11 inches is 23 inches. Right on, my party people. Then up next, let's take care of the 14 feet 7 inches. So remember, we'll do 14 times 12. We can do that on the side, or you can do it in your head. 14 times 10, 140. 14 times 2, 28. So that'll be 168. But we can go ahead and show that here on the side. 4 times 2 is 8. 1 times 2 is 2. 4 times 1. 1 times 1, 168. Cool. So we have 168 inches divided by 23 inches, and that's going to be the math. So let's see what we get. 23 going into 128. Well, looks like it's going to be just a guess and check system because 23 can't go into 1 or 16. So we're pretty much just guessing at this point. So let's take some guesses. 23 multiplied by 8. 3 times 8. Oh, I forgot to add the 7. Excuse me. I appreciate that. Thank you. Thank you. I'm getting ahead of myself. I'm trying to make good time here. So we have, again, that's going to be 168. Add the 7. Add that back. And that should give us 175. Booyah. So with that, I appreciate you, Dimitri. So boom, 175 divided by 23. Let's see how close we can get to 175. So let's try times 8. 3 times 8 would be 24. 2 times 8 is 16. Carry the 2 is 18. So it's 184. That's too much. That's too much. Notice that we're trying to get to 175. That's too much. So we'll move that off to the side, and we'll go ahead and see what happens when we do times 7. So here we go, 23 times 7. 3 times 7 is 21. 2 times 7 is 14. Carry the 2 is 16. 161. So my party people, how many whole pieces can we cut? How many whole pieces can we cut? Yeah, that's going to be 7. That's going to be 7 whole pieces. Exactly. So booyah, that's only going to be 7 whole. And that makes the answer here B. Right there. Right on. Has anybody here started off by getting questions wrong and then slowly you started understanding and even getting some questions correct? Has anybody felt like they've made the improvements in the middle of class? Hey, that's what's up, man. I'm telling you. Again, it's not about perfection. Like if you focus on the perfection or the end of the line, you forget about the process and how much you learn, not just about the ASVAB itself, but your ability to be a little tenacious, a little bit, just a little bit more enduring of what's in front of you. You got this, guys. This is what it looks like. It's a 2 hour class. We're almost at the end. And I know that a lot of us more and more are seeing how much better we're getting. So keep up the great work, guys. I'm proud of you. Again, just last reminder for those of you who are in the program, I'm going to go ahead, post these questions into the course as well as the recording. For those of you who are not in the program and want to join tomorrow's class and just make your overall time with the ASVAB easier, again, just check the link in the chat box there. That is the full program. That way you get access to everything. Over 500 recordings, all the classes coming up, all the courses with all the practice you need and step-by-step solutions. And you can text me whenever you need help. But with that said, who would like to try one more question out? Hey, let's go. I love the excitement. All right, cool. Let me see if I can find a fair question here. Yeah, I like this one. Here we go. Here we go. Timer is up, so you're getting a couple extra seconds. And there you go. My party people tried out. This is the last one of the day. And it looks like in tomorrow's class, we'll be able to do the remaining 8 or so. Sounds good. And looking at our final 4, 3, 2, and 1, everybody. Go ahead, put those answers in. What do we have? Go ahead. What do we have? What do we have? Okay. All right. All right. So let's get into this one. I've never seen us all on the same page with the same answer, not that much in this class. So we're either all correct or all wrong. I love these moments in class where that heartbeat just skips one. So let's go ahead and try it out. The goal here is finding the perimeter of the garden. And just like I always say, when it comes to dealing with questions that are geometry based, So area, perimeter, volume. Whenever we see that trigger word, perimeter, we need to know what shape we're dealing with because we want to visualize the situation ASAP. And it says rectangular garden. So we know that with a rectangular garden, we're going to have ourselves, well, not like that because that's not my drawing. That's how I draw perfectly with no use of technology. But yeah, so we have our length, and width, and we have to add all of that up. So what do we have for the length? Right there, 12 feet, 6 inches. So we'll have 12 feet, 6 inches there, 12 feet, 6 inches there. And then we have the width right here. So that's going to be 8 feet, 3 inches, 8 feet, 3 inches. So because we're adding everything up, we don't have to turn everything into inches to then turn it all the way back into feet and inches. We don't have to do that. All we have to do is just add up and see what's convenient. So again, remember that the perimeter is going to be 2 of the lengths plus 2 of the widths. So if I draw or write out the length twice, that's going to be 12 feet, 6 inches. And then we'll also have 12 feet, 6 inches, because again, the length twice, and then the width twice. All right, now that we have all of that, we add it all up, and now we're going to be able to just add everything up here. So 12, 12, 24, 16. So all of this together is going to be 40. And then we add all that up, and we're going to end up getting 12 inches plus 6 inches, so 18 inches. But that doesn't exactly look right, right? That's not properly written because 18 inches is bigger than a foot. So we actually had to go ahead and just take away 12 inches or take away 1 foot. So we can add 1 foot here. So that's 41 feet and 6 inches. That would be our correct answer, which makes it C. My party people, how do we feel about that one? I saw a couple people say it was pretty easy, right? But let me ask you this. Those same people that said it was kind of easy are, some of them I noticed were some of the people that were saying it was feeling really lost or impossible in the beginning of class. So this is good, everybody. This is good. Oh yeah, and for sure I'll explain this last part again. I got you. I don't want to leave you hanging. So when I saw the 40 feet, 18 inches, the reason I went ahead and said, hey, let's make this a little better. It's because 18 inches is over 1 foot. Remember, 1 foot is 12 inches. So all I pretty much did with that final 18 inches was I split it up into 12 inches, which is again the same thing as 1 foot, and then the 6 inches. And that's what was left over. And then I brought that extra foot, I brought that right over here. I took it away from here and I put it over there. Yeah, that's all I did, Laura. Sweet. Glad you got that. Everybody else, did that make sense there? I didn't mean to just kind of, glide over that part, but y'all let me know in the chat box if that made sense for you. And again, don't reveal your answer. Just type ready when you're ready. And looking at our final 4, 3, 2, and 1. Go ahead, put those answers in. Put a question mark next to your answer if it is a guess. Go ahead, my party people. What do you have? What do you have? All right, cool. So let's go ahead. Let's check things out. Let's see what we got. All right. So first of all, my party people, first things first, what is it that we want? What are we told that we need to find to get a correct answer? What do we want? What do we want? Go ahead and clarify that for me. Make a clear sentence or phrase. Yeah, we're looking for the average. We're looking for the average lap time in seconds. That's why. Okay, cool. I wanted to, never mind that. But we want the average lap time in seconds. So let's go ahead and grab red here. Jenna's average lap time in seconds. Give me one moment. I don't know why that's not working. There we go, finally. Perfect. So Jenna's average lap time in seconds. So pop quiz time, everybody. How do we find the average again? It's almost like we just talked about this maybe 3.5 minutes ago. How do you find the average again? Right, we're going to add everything up, find the total, and then divide. We're going to add it all up and then divide. So the average here equals, again, the total. And in this case, since we're talking about time, we will add the total time. And then we're going to divide by what number, everybody? Right. We're going to divide by 4 because we have 4 values. We have 1, 2, 3, and 4. Boom. So 1, 2, 3, and 4. So we're going to divide by 4. So to add everything up here, let's see if we can make this pretty easy. If we want to use mental math, we can make this process a lot quicker than we think. So let me show you how we can still be correct, but we can waste a lot of time. So allow me to move this down over here. So a lot of folks might try to do this. They might say, okay, over here, if I have 1 minute, 32 seconds, everybody, 1 minute is how many seconds? Yep, that's 60 seconds. So we'll say 60 seconds plus the 32. So that'll be 92. Some folks might continue on and say, okay, another minute. So that's going to be another 60 seconds, this time plus 29. So that'll be 89 seconds. You might see it again, another minute, 35 seconds. So you'll say, okay, 60 plus 35, and that'll be 95. And then we have 1 minute, 33 seconds. So you have 60 plus 33, and that'll be 93. So far, does this look like anybody's work in the problem so far? Does this look like anybody's work so far? Yeah, this is okay, cool. Again, this is not a wrong way to do it. Not a wrong way. You're still absolutely correct. You have all of the times in seconds. So now what we can do is we can go ahead and add everything up. And this is the part where I'm going to come back to and show you that we spent a little more time than we needed to. So here, we're going to have 92 plus 89 plus 95 plus 93. We got 4 two-digit numbers. And so we're going to say 2 plus 9 is 11, plus 5 is 16, plus 3 is 19. Then we say we have 9 plus 8, 17, 17 plus 9, 26, 26 plus 9, 35, 35 plus the 1 is 36. Okay, so we have 369 seconds. And then from here, we have our total. Again, that total time was 369 seconds. Then we divide by 4. So we can just proceed over here on the side, do some long division. And we'll go 4 into 36, which is a clean 9. And then we drop the 9 down. 4 goes into 9 twice. And then from there, we drop the 0. 4 goes into 10 twice. And then we drop another there. And then boom, drop another 0. And then we have 4 goes into 20 5 times. So that's just long division there going through. Once you run out and you still have a remainder, yeah, you can continue going because you look at the answer choices and there is a decimal for one of them, or two of them at least. So we have what we need. We're good. We have 92.25 seconds. Everybody, do we need to convert this back? Do we need to convert this back into minutes and seconds? No, we don't. We absolutely do not. And why is that, everybody? And it's, again, a mistake that I made while I was waiting for the timer to come down. I'm like, things feel too smooth right now. And I judged this problem based off of the similar one yesterday, forgetting that I said I put a little trick in there and I tricked myself. So the trick right here is we want the average lap time in seconds. You might notice that A and C, they're both the same amount of time. 1 minute and 32 and a quarter seconds is the same as 92 and a quarter, because the first 60 seconds is a minute, then the remaining 32 and 0.25, same thing. But because it says we want it in seconds, the only correct answer here is C. So there's the answer. So for those of us that pick D overwhelmingly, I think that you were able to add everything up and get the 369, but I feel like the moment that you saw 369 as one of the choices, you stopped working. Is that fair to say for some of us that picked D? Yeah, Ruby, Mason. Okay, that sounds right on par for you guys. No worries. No worries at all. So remember that we always want to start by reading the question and think about that connection or that formula that we might need before we actually do the math. That'll save us from stopping too early. Okay? Now, before we move forward, who wants to learn how to do all this part here, the adding up and this part a little faster? Who wants to see that done, again, in a very reasonable way, but much, much faster? All right, sounds good. So this is going to involve using just a little bit of mental math. So what I'm going to do is I'm going to copy this page over just in case I want to come back to it. So let me just copy it, paste it. All righty. Sweet. So now that I have that pasted, I can go ahead and mess around with this. So look at how much smoother this can be. So let me go ahead and move all that out the way. We know that the total, again, was going to be 369 seconds. And let me show you what you can do. Everybody, quick question. We already know a minute is going to be 60 seconds, right? Yeah, we already know a minute's going to be 60 seconds. So here's my take. I'm going to say, hey, we got 1 minute here. That's 2 minutes, 3 minutes, 4 minutes. Every minute is 60 seconds. So since I have 4 total minutes, I'm just going to say in my head, 4 times 60, and that's going to be 240 seconds. So I have that already in my head so far. Now I'm going to make my life even easier because I'm going to take a look at everything over here. The partial minutes, so the seconds that I have. Again, every 60 seconds makes a minute. Here's what I can do. I can go ahead and just, there's 2 real ways. There's one way that I prefer, but I'm going to go the normal way. You can just start counting up the seconds here. You can say 30 plus 30, that's 60. Another 30 plus 20, that's 50. So we can grab that right here. Boom. That's another minute or another 60 seconds. Another 50 seconds. Then you can just say 8, 10, and then 9. And you can just write it out that way. Add it all up, and you're good. Add it all up, and you're good, because that'll be 110. Bring that in, 120, 129. And so there you go. Your final answer would be 240 plus 129. This, everything I wrote down, the reason it looks kind of messy is because this is meant to be done in your head. Knowing that the first, let me bring that back, there we go. Knowing that 4 minutes would be 240 seconds. And then you would just say 240, 270, 290, 320, 350, 355, 358, 360, 369. And you're done. But that is a mental math technique that you can use to kind of go through everything in a much faster way because you're not writing anything down. My party people, does that make even a little bit of sense to you in terms of looking at things from a mental math approach. Yeah, no worries if you're good with the first way, because think about it. The advantage of the first method here is that this provides the security blanket of accuracy. You can work it out and you can absolutely know that once you're done, hey, I got it down, I wrote it down. I'm not confusing myself by trying to keep it all in my head. I get it. Yeah, so you're good. But I'm just encouraging you that with time, you'll see that because the ASVAB is a timed test and you're competing against other people, it might be in your best interest to not just know how to do something on paper, but be able to save time by doing it in your head when you can. That's all I'm trying to say. Yeah. So yeah, you can keep your preference. I'm not here to, trying to preach the gospel. I'm just trying to make sure that you know what the next step or how much more efficient you can get. So we are good here with the first question. Who is ready for the next one? Right on, right on. I'm gonna reset that timer. Let's bring it right on out. All right, perfect. And here we go, my party people. 3, 2, and 1. Again, don't reveal your answers. Just type ready when you're ready. And that is time. My party people, go ahead. Put those answers in. What do we have? What do we have? All right. Okay. Got confused? Hey, no worries at all. Because this is definitely going to be one of those questions that if you're not careful enough, you're gonna get burned. So no worries at all. If you feel like you were confused or lost on this one, I'm going to show you how it's really just one minor difference that's going to make the difference between getting it right or wrong. So here we go. First things first, everybody, as always, read the question, give me a word or a phrase quickly on what we want. What do we want? Can you state it? Can you verbalize it or write it down here? What are we looking for? No, I'm not saying what topic is this. This is a proportion question. There are ratios involved. I'm asking you if you know what we're looking for from the story. What is the story having you find? What do we want to find at the end of the day? Yeah, we want the number of pounds of flour to keep this recipe the right way, right? We want the number of pounds of flour. You got to be specific. Again, being specific really helps you get at ease because sometimes it's just too easy to freak out and give up too early. So here, we're saying, how many pounds of flour do you need? Sounds good. And we got to maintain the correct ratio. So that's what gives it away that this is a proportion question. Because anytime you're saying, hey, keeping the same ratio or maintaining the ratio, that's a dead giveaway that that's a proportion. Typically, problems aren't that overt, but I wanted to make it a little more clear in this one because I wanted to show you that you still needed to do the setup correctly. So we want the pounds of flour, right there. And you see that we have 1 pound, 8 ounces of sugar with that. So we can actually make the connection right now because we say that we have blank pounds of flour with, and I'm going to highlight this in blue, 1 pound, 8 ounces of sugar. So 1 pound, 8 ounces of sugar. My party people, are we good so far? Again, we're looking for the number of pounds of flour that goes with 1 pound and 8 ounces of sugar. Is that clear just from what we highlighted so far? Just that one sentence. If we have 1 pound, 8 ounces of sugar, how many pounds of flour? So far, so good? All right, cool. Remember, we always want to start with the easiest part. What the heck are we here for? All right, that's always what we want to start with. Now we're going to start sorting through the information, seeing what we can pull through to make some sort of setup. So here, a recipe calls for flour and sugar to be mixed in a ratio of, oh, right there. This is going to give it away. A ratio of 5 pounds of flour for every 12 ounces of sugar. So here's what we need. Here's the ratio. The ratio says, hey, we need 5 pounds of flour with, and then it says, right over here, 12 ounces of sugar, right here. 12 ounces of sugar. All right, great. Sounds good. Everybody, did I write everything down correctly? I didn't make a single mistake, right? I wrote everything down correctly, looking for the number of pounds of flour with 1 pound and 8 ounces of sugar. Then we have 5 pounds of flour with 12 ounces of sugar for the ratio. So confirm for me, everything I wrote down correctly, right? Great. Cool. Let's go ahead and set up our proportion. Hit me in the chat box now. Pop quiz time. What is the main idea for proportions? And again, if you're new to the program, that's going to be Arithmetic Reasoning Bootcamp, unit number 2. That's proportions. So what's the main idea? Starts with a C. Compare the same what? Yeah, compare the same things in the same way. Notice that we have flour compared to sugar, flour compared to sugar. So we have the same things being compared. But here's why it's not in the same way. Think about it. Let's zoom on in over here. Let's check this out. We have flour and then sugar on the right side, flour on the left, sugar on the right. So that's good. That's cool. I even wrote flour in red, sugar in blue. So we're good there. Here's what's not good. I'm comparing pounds of flour to pounds and ounces of sugar. then pounds of flour, but then ounces of sugar. So if you look over here, pounds and pounds, that's good. We're comparing the same things and they're being compared in the same way. Flour is in pounds. But when you look over here, this is where we start having an issue. We have pounds and ounces, and then just ounces. My party people, do you see that we're going to have to change this over here probably into just ounces? Because that way we can say pounds to ounces, pounds to ounces. My party people, do we see that? We have got to compare the same things, and not just the same things, but we have got to do it in the same way. We've got to do it in the same way. And so here's the one thing we need to do. Oh, no worries, Angelique. So here's what we need to do. We're going to grab the 1 pound and 8 ounces. I'm going to just bring it right on up over here for a moment. And we're going to turn this into ounces. Everybody, how many ounces are in a pound? Yep, that's going to be 16 ounces. And then we still have the 8 ounces right here. What's 16 plus 8? Help me out. Yeah, that's going to be 24. So we add that, and that'll be 24 ounces. If we put that back, this is actually going to be a really, really easy question. Because if we take a look at the comparison now, everybody take a look at what happens. The ratio is 5 pounds of flour with 12 ounces of sugar. Everybody, what happened from here to here? 12 to 24. What do you call that? What did we do to the 12? What did we do to the 12 to get to the 24? Yeah, we just doubled it. And everybody, if it's a ratio or a proportion, we know that if you double one thing, you double the other. And so this technically right over here would be 10 pounds. That would be the final answer. But I'm not going to sit here and pretend that everybody knew that. Let's go ahead and do it the normal way. But just know that 10 is going to be the answer that we get to. But let's put X there on the side and write 10 right there. Let me show you. This is how you can set up a proportion. You can go ahead and proceed to just say, hey, X over 24. I'll write that over here. We'll just say, again, X over 24 equals, and then we'll do another fraction on the right side. Same comparison. We said X over 24. Then we'll say 5 over 12. 5 over 12. Now that we're here, allow my screen just a brief moment to go ahead and catch up. There it is. So now that we're here, we can move forward to cross multiply and divide. So let's do that. X times 12 will be 12x. And then we have 24 multiplied by 5. My party people, 24 multiplied by 5. Let's go ahead and check that out. 24 times 5. 4 times 5 is 20. 2 times 5 is 10. Carry the 2 is 12. So now we have 120. Now, what do we need to do here, everybody? What's the next and last step? Yeah, we got to divide. Divide what and where? Divide what and where? Right, divide both sides by 12. Divide both sides by 12, and we are all good. So divide by 12 here, divide by 12 there. Once we do that, it cancels on the left side, leaving us with x equals 120 divided by 12, which is going to be 10. And there you go, 10 pounds of flour. There's our answer. My party people, do we see the big difference that knowing the rules for proportions made? Knowing that we had to compare the same things in the same way, and then seeing that, hey, if this is given in ounces, this needs to match. And as long as we did that, once we set it up, oh man, this is easy. This is straightforward. The answer is going to be C and we're done. But it's not going to feel easy until you put in the work to understand what's going on. You guessing you still got it right, Ozzy? Hey, I'll take it. But the next step is going to be to learn how we actually get it right. Alexa, how do we get 12 over 12? Do you mean 120 over 12? That is 120 because that's what 24 multiplied by 5 was right here. 24 times 5 is 120, so that's 120 right here. And then because we had 12x equals 120, we divided both sides by 12. Let me know if that makes a little more sense there, my party people. Yep, I got you. We'll zoom out. Yeah, feel free to take a screenshot if you need to, but we are set to move forward. Hey, let's we got a 52. Let's go. If that was the pie cat, then you have the verification to go. But if it was the real ASVAB, congratulations. That's awesome. So Ruby, the easy way to do this would be to understand that the idea of ratios. If you know idea of ratios and quick conversions, you can see that, hey, it says 5 pounds for every 12 ounces of sugar. Sugar, 12 ounces. If you look at 1 pound, 8 ounces of sugar, that's 24 ounces. 12 ounces to 24 ounces, that's double. Take 5, double it, that's 10. And you're done. That would be the quote easy way to do it, but you can't get to the easy way until you actually know this like the back of your hand. So with that said, are we ready for the next one, my party people? I got you, Ruby. Are we ready for the next one? All right, sweet. Let's go ahead and set up that timer again. And here we go. All right, and time is up, my party people. What do we have? What do we have? Put those answers in. Put a question mark next to your answer if it is a guess. All right, sounds good. Let's go ahead and check things out here. Let's see what we have. All right, so after this question, we're going to go ahead and go back to back on a few of them. We're going to go ahead and do two back to back after this one. So here we go. What we see here is we want to know how much it's going to cost Sally to ship her package. Okay, cool. So let's just go ahead and highlight that right there. How much will it cost Sally to ship her package? My party people, is that what we first did in this question? Is that what you first did? We want to know how much the cost is. So we're thinking, hey, it's a dollar amount to ship the package. Are we good on that? We're just looking for that final dollar amount. All right, sweet. Now, from here, I think this is a situation that we can really get behind. We can really imagine this. If we're trying to ship something, okay, we're trying to ship an item that is 4 pounds and 9 ounces. Okay, so we have the weight right there. So let's just write that down. So the weight is 4 pounds, 9 ounces. Okay, and then up next, we see that it says the shipping company charges a flat fee of $8.50 for the first 3 pounds and an additional 40 cents per ounce for any weight over 3 pounds. Okay, my party people, does this sound like multiple steps here? Does this sound like we need to think about the weight before we just go ahead and multiply or add or whatever? Does it feel like we really need to think about this? Yeah, we do. We absolutely do. Because notice that how much you're paying depends on the weight. And you're getting charged differently for 3 pounds and below versus over 3 pounds. So we really have to think about that. So let's write down the rule here. So the first 3 pounds, everybody, how much did they say we're charging for the first 3 pounds? How much are we paying for the first 3 pounds? Exactly. The first 3 pounds is just going to be $8.50 right here. It's just going to be $8.50. Boom. First 3 pounds. So then everything over is going to be 40 cents per ounce. Now, this is the biggest question here, though. The biggest question is, hey, how much or how many ounces are we dealing with over 3 pounds? So if we think about that, well, we have 4 pounds, 9 ounces. My party people, if we take away the first 3 pounds, we are left with what? We are left with what? After we subtract the first 3 pounds, we are left again. Yep, we're left with 1 pound, 9 ounces. That's what we're left with. But think about it. If we need to do 40 cents per ounce, we need the weight in ounces because we're not multiplying by pounds, we're multiplying by ounces. So we're going to need to write this in ounces. So if we have 1 pound, 9 ounces, everybody help me out real quick. How many ounces are in 1 pound? Yep, 16 ounces in a pound. So we'll just write 16 ounces. Nice and easy there. We still have the 9 ounces from before. Add that together and we get what? Yeah, 16 plus 9 is 25 ounces. Booyah. And so there it is, 25 ounces. What are we supposed to do with that 25 ounces, everybody? What are we supposed to do? Yep, now we're supposed to multiply by that 40 cents. So let's go ahead and do that here. If we do that, we'll have, let's just use purple again. So we'll do 25 ounces multiplied by 40 cents, which is going to be 0.4. But once we do that, we'll have 5 times 4, which is 20. 2 times 4, which is 8. Carry the 2. That's going to be 10. So we have that right there. We bring one decimal place back. And so that's going to be right over here, $10. That is $10 for that extra weight. So how many people got excited with that $10 and we said, oh, there's our answer right there. That's going to be B. Who thought that accidentally before they thought or remembered that the first 3 pounds is $8.50? So yeah, don't get too hasty. Don't forget. And so the final answer is going to be, hey, $10 plus the $8.50. Once we have that, that's going to be $18.50. And so that will be our final cost to ship whatever package this is. $18.50. Answer is D. And so, Nikki, even if you didn't get it right, you were close. That's good. Now, can we point out the mistake that we made? And that's a question for everybody here. It's not just about getting it right or wrong. Again, can you repeat the success if you were right? And can you make sure that you don't repeat the same mistake if you were wrong? So, yeah, we just have to go ahead and just embrace that mistake, embrace what happened, learn from it, and then try our best again next time around. That's all we can do. So how are we feeling at this point, everybody? Are we feeling better, the same, or worse about unit conversions? Sweet. You just rushed and you were wrong at first? Hey, no worries. No worries. It takes time. It takes time. All right, let's go ahead and give it another shot. Let's go ahead and look at another one here. And for those of you that had an issue with the blurriness, is it much better now in terms of being able to see the resolution on the screen? Is it better? All right, cool. Sounds good. Yeah, I didn't realize I had a video editing software in the background running, and that was taking a lot of CPU, which for some reason affected the stream, but fixed it all up in the middle of the problem. So thank you guys for being patient on that. I knew my laptop was making weird noises for something. So let me go ahead and get the timer right back up. And there we go. All right. So again, everybody, next question, short-term memory. It's a brand new question. If you got the last 1 or 2 or 3 right, don't get cocky. Even if you got the last one or all of them wrong, don't stay in that hopeless despair. Make sure to give yourself a fresh opportunity. Start by reading the question sentence so you know what you want. Then look at the information you have and try to think about reasonably how you can get from what you have to what you want. And if unit conversion just so happens to be part of the process, then go ahead and point out where you need to convert units before you do the actual math. Again, if you can just plan out what you're supposed to do before the time is up and you're correct in your plan, I will take that as a success. Then the next step is to do the math. But can you reason with it first? So here we go, my party people. Let's go ahead here, get the timer, and 3, 2, 1, let's go. I put those answers in, my party people. How we feeling? How we feeling? Put those answers in. Put those answers in. Yeah, no worries if you're stuck. No worries if you're stuck. 'Cause remember, my job is to help you take you from where you are to the next step. I'm not trying to have you be, a full-fledged perfectionist in 1 2 hour class. That's not how this works. I just want to say that I want to reveal to you and affirm to you, hey, you did these parts right. Okay, this is where you got stuck. Okay, and here's where we should have done. And I want you to reflect on what you did, why you did what you did, but why the other way is actually the right way. It takes attention. You have to pay attention to this. And that's why those of you that have been showing up to classes, watching the recordings, going into the program and doing those practice problems and practice tests, like y'all are the ones that are succeeding because of it. So again, keep up the great work. So here we go. Let's get the timer out of the way and get started right away. Everybody in the chat box, in a word or phrase, be specific. What am I looking for here? Yeah, we're looking for the area of the patio in square feet. The area of the patio, but we want it in square feet. Right here, area of the patio, and they specify square feet. Sounds good. Sounds good. So here is how we're going to get this done. Here's how we're going to do it. There are, again, 10 different ways that we can go about this. I'm going to express to you, I would say, probably the most straightforward way that I can. So here's how I would do it. I would go ahead and draw this square out. Let me go ahead and just do it like this. Cool. And then we know that each side of the square measures 5 feet 4 inches. 5 feet 4 inches. Okay, my party people, help me out real quick. What's the formula for the area of a square? What's the formula? Yeah, that's going to be side times side, or just, multiply the sides together. Remember, a square is a rectangle. So this is pretty much just saying length times width, but since they're the same, we can just say side times side. So yeah, here we go. We'll go ahead and just write this right over here. Area equals side times side. Okay. And so let's write each side down. But what's the problem going to be, everybody? Why can't I just write 5 foot 4 inches times 5 foot 4 inches? What's the problem again? Why can't I do that? Right. We want it in square feet. So does that mean that we would be smart to turn this into just inches? No, we shouldn't. Remember, we want it in square feet. So here's what we can actually do. We can actually write 5 foot 4 inches. We can write this as a mixed number. We can write this as 5 foot, or not 5 feet, but we can write it as 5 and 4/12 of a foot. Why did I write it like that, everybody? I wrote it like this because 4 inches, if I'm converting that to feet, that's 4 out of 12 inches that you need for a foot. So instead of saying 5 foot 4 inches, we can say 5 and 4/12 of a foot. My party people, does that make sense to you? You can actually grab any ruler in your house right now, and you'll see that 4 inches is 4/12 of the space for a whole foot. And that's all I did here. I just turned it from 5 feet 4 inches to 5 and 4/12 of a foot. That is one way you can do it. Another way you can do it is just turning 4/12 into an actual decimal. The other way that would look like would be 5.3 repeating. The way that would look, everybody, is like this. If I wanted to turn 4 inches into feet, we would have to go ahead and divide by 12. If I did that and I did 12 going into 4, here's what we would do. Write a decimal there just in case. But you see that you would have 12 go into 4 It can't. Then you have 12 go into 40. That would be what? 3 times. Subtract 36, and then you get 4 again. You drop a 0, and the same process repeats. 12 goes into 40 3 times, and then you would continue just subtracting 36, get 4, and keep dropping forever. So that's why I say 0.333 repeating forever. So you could get it like that, and that would be the same thing. So that's the same as this. Or you could say 5 4/12 of a foot. Who prefers the fraction? Who prefers the decimal? Y'all tell me. What do y'all prefer? Do y'all prefer the fraction or the decimal? Because I'm going to do the work with both of them just to show and prove a point. But we'll see. Okay, we have more people preferring the fraction than the decimal. And don't worry, I'll go ahead and show you both ways. We're good. We're good. So here, now that we have our area formula, again, I'm going to show you how to do it both ways with both the fraction and the decimal. So I'll start off with the fraction. We have 5 4/12 multiplied by 5 4/12. Once we're here, we'll have to convert these mixed numbers into improper fractions, and here's how we do that. We'll go ahead and multiply the whole number by that denominator. So 5 times 12, that's going to be 60. Then we add it to the top. So that would be 64/12 multiplied by the same thing, 64/12. Now that we're here, we're basically multiplying two fractions, and it would serve us well to go ahead and simplify before we continue. My party people, what's a number that can go into both 64 and 12 that we can divide out? What's something we can divide out just to make things a little easier? Nope, not 6. 2 would definitely work, but there's a bigger number that could work. Because you might notice that 4 times 3 is 12. 4 times 16 is 64. So if we do that, we can go ahead and just go ahead, divide by 4 on top and bottom, and that will give us 16/3. And again, same thing over here, 16/3. So once we're here, now we'll go ahead and multiply. 16 times 16, what's that going to be? 16 times 16, 6 times 6 is 36. 1 times 6 is 6, carry the 3 is 9. Next line, 6 times 1, 1 times 1, add that all up, and we are going to get ourselves 9 plus 6, 15, and 256. And then we have 256 over 3 times 3, which is 9. Now that we're here, what's the last thing we need to do, everybody? Because this is 256 over 9 square feet. Yeah, all I got to do now is just divide. See what that value is. So from here, we'll go ahead and do that. 9 going into 256. So 9 goes into 25 just twice. So we'll subtract the 18, getting the 7, dropping the 6. 9 goes into 76. That would be 8 times. We'll subtract the 72 to get 4. From here, well, we are going to continue going because you see that we have 28, but is it going to be 28.4 or 28.9? Which one is it going to be? So from here, we'll go ahead and continue, dropping a 0. 4 or 9 goes into 4. Well, that would end up being 4 times. And now that we're at 28.4, what's the answer going to be, everybody? What does the answer have to be at this point? Yep, it would have to be B, 28.4. And there we go. 28.4 square feet, and we are good. Yeah, absolutely going to feel a little rough. Absolutely. Yeah, don't blame you at all. Don't blame you at all. But I want to go ahead and point something out. Something I would have wanted to point out is this, everybody. I wanted to point out that when we were here and talking about turning the 5 feet 4 inches into a mixed number, or keeping it as a decimal, I was really surprised that most people said, hey, I like the fraction. I like the fraction, coach. I was really surprised at that because when you looked at the answer choices, notice how 3 of them are decimals. So I found it a little strange. And, obviously it's in the moment, you're going to be in the test and you're going to make decisions. But I noticed that y'all preferred to work with the fraction, even though you knew it would have to be turned into a decimal later on. So, in truth, the most efficient way would have actually been going with the decimal. Because notice, look at all of this work over here. All of this can be avoided. Everything here, all of that can be avoided. If I go ahead and say, you know what, let me just say that this is about 5.3. Okay, I'm not going to do the 3, 3, 3 forever. I'm going to say, let's pretend it's about 5.3. I know that my area is going to be the side times side, which is 5.3 times 5.3. And look at this, everybody. Watch this. 5.3 times 5.3. 3 times 3, that's going to give you 9. Then we have 5 times 3, that'll be 15. Okay, then we'll put a 0 right there. Then next line, we have 3 times 5. Okay, that'll be 15. Then we have 5 times 5 is 25. Carry the 1 is 26. Add that up. And then we have 9. Then we have 5 plus 5, which is going to be 10. 1 plus 1 plus 6 is going to be 8. And then we have the 2. We have 2 decimal places, 1, 2. And so we'll put that right over there at 28.09. Now, my party people, this is going to be on the low end because notice that we used 5.3, not 5.333333333 forever. So it's going to be a little bigger than this. Now, the question is, do we think it's going to be, again, a little bigger at 0.4 or going all the way up to almost 29? And so with reasonableness, we would be able to tell that, yeah, B is the answer. It'll be a little risky, but it does save you a ton of time by staying working with a decimal. My party people, does that make even a little bit of sense? Again, just take a look at the work that we did here versus all the work that we did from there. Yeah, so we knew that we would have to go up a little bit because we rounded down. We used 5.3 instead of 5.3333 dot, 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 dot. That is bigger than just 5.3. Or $5.33 is bigger than $5.30. So that's what I mean by that. So if you know how to work with decimals, again, as always, it's always coming down to how much experience you have. But if you have that experience, you can make some decisions that will save you a little bit of time. So I got it in the beginning from 5 foot 4 inches, this is pretty interesting. I know that 4 over 12 is the same as 1/3. 4 over 12 is the same as 1/3. So because I knew that that was 1/3, I knew that when you go ahead and do 1 over 3 or divide it, it's going to be 0.33333333 forever. That's how I knew, Stephen. So I do apologize for, again, making that jump without verifying it. But I did actually verify it here with 4 over 12, which is the same thing as 1 over 3. So whether you love or hate this question, you got to prepare for something like this. Are we ready to go ahead and do 2 questions now back to back? Are we ready? Oh, wait, actually, everybody, we only have 3 questions left from this entire set. So would you guys like to just go ahead and do all 3 back to back and then we review it? Yeah, cool. Sounds good. Let's go and knock it out. No problem. All right. Sweet. Sounds good. So I will give you any conversions that you might need. Yeah, I'll give you anything you might need. So here we go. Here's the next one. Let me get the timer up on the screen. All right, 3, 2, let's go. And looking at our final 3, 2, 1. Go ahead, put those answers in, my party people. What do we have? What do we have? Put those answers in, question mark next to your answer if it's a guess. And we're going to move forward to question 2, then 3, and then review all 3 back to back. So let's see if you have that tenacity. Let's take a look at the next one in 3, 2, let's go. You got this. Put those answers in, my party people. What do we have? Put a question mark next to your answer if it's a guess. And again, no shame. Put your best foot forward. Pretend that this is the last question on the test, and you have to put an answer up. And we gave the full 3 minutes to think about it, and we're there. Awesome. All right, one more to go, guys. One more to go. Again, forget everything that you've done previously. Don't assume that the next one will be as easy or as hard. Just treat it like a brand new question, a brand new opportunity. 3, 2, 1. Let's go. And looking at our final 3, 2, 1. Go ahead, put those answers in. What do we have? What do we have? Right on, my party people. Let's go ahead and get that timer out of the way and let's party. We got this. So let's move back to the first one here of the 3. And let me ask you, my party people. Let me ask y'all. Oh, yeah, Ruby said that she could only stay for another 15 minutes there. But y'all let me know, how do we feel after those 3 questions? Do you feel like, hey, I got at least one of them right? I got at least 2, maybe. I know I got all 3. I had no idea what I was doing. How did we feel? Again, how did we feel? I don't mind if it's one way or the other. I just want to understand where you feel like you are before we go over it. Okay, so I'm seeing most of the answers, between, hey, I'm lost to 1, maybe I saw 1 or 2 of those. I got 2 right. Okay. So again, I just hope that this class serves you well in terms of, look, if we took the unit conversions out of the way, would this be easy? Let's talk about this first one, everybody. In this first one, if we're trying to find the area of a rectangular metal plate, would that be easy if we didn't have to convert units? If it was just, hey, what's the area? We got 5 meters here, 7 meters there, find the area in square meters. Would it be very easy if we didn't have to convert units in the middle of the problem? Right? Yeah. Okay, so we agree on that. Now, I want you to use that, that epiphany or revelation to yourself, use that to understand that the problem is not word problems. The problem is right now, if that's your issue, it's unit conversions. So in the same way that I have y'all practice multiplying, your multiplication tables, working with large numbers, decimals, fractions, again, unit conversions are just the same. So here we go. We want to find the area of the rectangular metal plate. And so that's going to be length times width. And we see that we want it in square meters. What's the problem? The problem is that we're given the length as 150 centimeters and the width as 45 centimeters. So we have the conversion right over there. 1 meter is 100 centimeters. So everybody, what do I do to turn centimeters into meters? What do I do? What do we do? Steven says multiply. Multiply by 100, I mean, okay. Divide by 100. Okay, so it looks like we are arguing now, right? Looks like some of us are saying one way, others are saying the other. Let me show you how to get this done. So right over here, I'm going to say we have 150 meters, or centimeters, excuse me. And we're going to use what's called a conversion rate. If you were here in yesterday's class, or if you've gone through a unit conversion class with me before, when we're converting, if you're ever confused, always use a conversion rate. So the conversion rate is, again, 1 meter equals 100 centimeters. And here's what I'm going to do. I'm going to multiply by a fraction. And the goal of multiplying by this fraction is getting rid of the old unit to leave the new unit, or meters in this case. So what I'm going to say is, hey, if I want to get rid of centimeters, everybody, true or false, we have to put it on the bottom. If I want to cancel centimeters, there has to be centimeters down here. Right on. So we'll grab this, 100 centimeters, put that right down there, and the 1 meter, we'll put it right there. Yeah, that's how we do it, so we can cancel it out. Now we'll see properly that the centimeters get canceled, leaving you with just meters. That's what we want. And you'll now see that we'll have 150 times 1, which is just going to be 150 over 100, and that'll be in meters. And my party people, what's the easiest way to divide by 100? what do we do with the decimal place? What do we learn to do with the decimal place? Move that down. So to divide by 100, what's the easy way to do that? What can we do with that decimal? Yeah, we can move it over. And how many times? Yeah, twice to the left. When we're dividing, we're getting smaller. So we'll divide it by 100, move it twice to the left. So we'll go 1, 2. So this would be 1.5 meters. And then over here, 1, 2. That'll be 0.45 meters. Once we have that, my party people, we're good. Because now we have it in meters. Now we can find the area. Now we'll be good. So we'll have 1.5 multiplied by 0.45. And now that we're here, we're good. Let's go. So we'll do it. We'll have 1.5 multiplied by 0.45. 5 times 5, that's going to be 25. 1 times 5 is 5. Carry the 2 is 7. Then we have 5 times 4, which is 20. Carry the 2. 1 times 4 is 4. Carry the 2 is 6. So now we have 5, 7, 6. And everybody, how many times are we moving the decimal place over? Yeah, 3 times, because we have it 1, 2, 3. So we'll go 1, 2, 3. Boom. 0.675 square meters. That is going to be the final answer. And boom, we are now good. Answer is B. So V, you had a light bulb moment there. What happened there? What happened? Talk to me. And anybody else who feel like they were lost, because that was a lot of us. Did we see how we can get it done here? Just knowing how to convert between centimeters and meters was the barrier, I would say. You messed up on the decimal part, V? No worries. We can correct that moving forward, right? What about everybody else? Did we see, again, we already said, if we didn't have to convert units, it would be as easy as length times width. But do we see how to actually convert between meters and centimeters? Cool, right on. And again, even if it's a kind of, remember that we are overall, if you want to practice overall unit conversions, you're going to Arithmetic Reasoning Unit 3. That is unit conversions. So go ahead and go there if you need more practice with this. And I'm assuming it's going to be most of us here, so you know where to go after class ends. But let's go ahead and move it over to the second question here. The second question says, hey, what's the total weight of all the boxes and crates combined? How did y'all feel about this one? Did y'all feel like this one was doable? Did you feel like you were really confused on this one? How did you feel? Total weight of all the boxes. Oh, for some reason it's not catching it, but we're going to say total weight of all the boxes and crates combined. And yeah, Priscilla, after the class, tomorrow morning, once the video is processed, you'll go to the ASVAB class recordings course, and then just scroll down into June. It'll be the first, the second section there. You go to June, and you'll see this posted right after yesterday's recording too. So before I continue, everybody, give me a yes or no. Are we paying attention that we want the total weight, all those boxes, all those crates, bring them together, find the total weight? Are we good on that? Sounds good. So we have all the boxes plus all the crates. Sweet. Sounds good. So let's get it done here. So we have 12 boxes. 12 boxes, and each of them weighs 5 pounds, 4 ounces. So I'm going to write that over here. So 12 boxes. And each box is, again, 5 pounds, 4 ounces. So on the other hand, in blue, right over here, we have 18 crates. and each of them weighs 8 pounds, 9 ounces. Okay, cool. So we have 18 crates. And then each crate is, again, 8 pounds, 9 ounces. Cool. So let's zoom on in over here and let's get our hands dirty. Because looking at this, well, it's going to be pretty straightforward. Because the final answer is going to be in pounds and ounces as well, I can just go ahead and multiply the 12 by the pounds, then the 12 by the ounces. And then if we have ounces that are over, over 16 ounces, we know that we're going to have to convert it to pounds. So for example, everybody, if we, did our multiplication and we saw that we had 20 ounces, is it pretty straightforward for y'all to see that if I divide 20 by 16, I get 1 pound with 4 ounces left over? Is that fair to y'all? If we divide by the 16 ounces per pound, whatever number of ounces we have, we'll be able to see how many full pounds we have and how many leftover ounces we have. All right, so let's go ahead and get this done, and I'm going to show you in real time what that looks like. So let me just get rid of this over here. And here we go. We'll do 12 times the 5 pounds. That's going to be 60 pounds. Then we have the 12 times the 4 ounces. That's going to be 48 ounces. So again, pounds and ounces are going to be different, everybody. I'm going to have to turn these ounces into pounds. My party people, what is 48 divided by 16? What is that going to be? Giancarlo, that is correct. That is going to be 3. That's going to be 3. So once we have that, that's going to be 3 pounds. So if we bring that back right over here, we now have how many total pounds, everybody? Yeah, we now have 63 pounds for all of those boxes. So I'm going to highlight that and keep that right there. We got 63 pounds for all 12 boxes. Now I'm going to come over here and work on the weight for the 18 crates. Let's go ahead and do that now. So we see that we're going to have the 18 crates multiplied by the 8 pounds. And then we have the 18 crates multiplied by the 9 ounces. So 8 times 8, that's going to be 64. 1 times 8 is 8. Carry the 6 is 14. So we got 144 pounds here. And then on the right side, 8 times 9, that's going to be 72. 1 times 9 is 9. Carry the 7. That's going to be 16. So this is 162 ounces. But everybody, if we have 162 ounces and I'm trying to turn that back into pounds and ounces, well, let me show you something. Let me show y'all something. If I divide by the 16, we're going to get how many full pounds, everybody? How many full pounds? Think about it. It's in the 160. 162 divided by 16. How many times can 16 go into 162 without going over? Yeah, Rasheen, it's going to be 10. It's going to be 10 because 16 times 10, that's 160. So that's going to be 10 pounds. And then over here, we have 2 ounces left over. Because again, 16 times 10, 160. And then you have 2 more left over right there. So we'll put that right there. Okay, cool. We're good. We have the 144 pounds from earlier. And then we have the extra 10 pounds and 2 ounces. That's everything that we're trying to add up together, everybody. So let me write that all down here. We're trying to add up from the 12 boxes. We got the 63 pounds right here. Then we also have the 144 pounds. And then we lastly have the 10 pounds and 2 ounces from that conversion. And so when we add this all back up, we see that we're going to have what? 3 plus 4 plus 0, so that's 7. Then we have 6 plus 4, that's going to be 10. Add the 1 is 11, and that's going to be 2. So we have 217 pounds, and then we have the 2 ounces that was already there. And there we go. There's that final answer, and that is going to be B. My party people, how are we feeling about this one? Is this one doable? Just a lot of math, right? I think that this one's very doable. It's just a matter of how quick are you with your calculations? Because think about it. If they said, hey, let's forget about the ounces. If I just said, hey, we got 12 boxes that are 5 pounds each, 18 crates that are 8 pounds each, y'all would be having a field day. Y'all would do 12 times 5, then add that with 18 times 8, and you're done. So I want to make sure that y'all understand, again, unit conversions are just part of the process in some questions. You have got to be ready to convert units as soon as you know that you need to. Hey, Shedrick, I'm glad that's what you did there. Let me look at these comments here. Yeah, with the practice, it can absolutely be done. Again, Arithmetic Reasoning Unit 3 for unit conversion word problems. Let's go ahead and get into the next one here and the last one here. So now we're looking at a distance, rate, and time question. We're looking at a distance, rate, and time question. So question reads, what is the distance in miles between the two cities? Oh, and sorry, just a quick pause, everybody, just to go back and answer Lewis's question. I got you. So Lewis asks, hey, why did I divide the 48 by 16? And that's because it's 48 ounces. Remember that every 16 ounces is going to be 1 pound. So you're basically dividing by 16 to see how many pounds are in there. And so we divide by 16 and we get 3 pounds. And that's what we bring back right over here. So we took that, threw it back with the 60 and the 3, and we got 63 pounds. So Lewis, hopefully that makes a little more sense there. Cool, gotcha. So here we go. So in this final question, again, what is the distance in miles between the two cities? So, okay, we want the distance and we want it in miles. So I'll write that out. Next thing, I see that it says a train is traveling at a constant speed of 50 miles per hour. Okay, so my rate is 50 miles per hour. And then we see that it says it takes the train 2 hours and 45 minutes to travel between the two cities. Okay, so the time is going to be 2 hours, 45 minutes. My party people, are we good? Did I write down all of the information correctly? Did I write it all out correctly? Sweet. Right on, right on. All right, so here's what we're going to do now. What we're going to do now is understand that if we want to set up the distance, rate, time formula, if we want to set this up, we got to be consistent, everybody. Let me look at my rate. My rate is miles per hour. Miles per hour, distance over time. Distance is in miles. My party people, is the distance up here in miles that we're looking for? You know, is the answer that we're looking for in miles? Yep, absolutely. We're looking for the distance in miles. So miles per hour, that checks out. But what about the second part? Miles per hour. Everybody, is our time written in just hours? Is our time written in just hours? No, it is not. So that presents a little tiny bit of an issue. And that's okay. That's absolutely okay. All we have to do is just turn this into just hours and we're good. And the great thing is, everybody, it's super easy. Let me show you how. 2 hours and 45 minutes is the same thing as saying 2 and 45 out of what? 2 and 45 out of what, everybody? Yeah, out of 60. 2 and 45 out of 60 hours. And this is what we're supposed to do. When we convert this into a decimal, let's just go ahead and try to simplify first. I can divide 15 from both the numerator and denominator, and it's going to reveal that this is actually something very straightforward. 2 3/4 hours. Everybody, 3/4. How can you write that as a decimal? Just listen to that. 3/4. What is 3/4 as a decimal? This is something that you shouldn't even have to write out. This is something that you should know off the top of your head. Yes, 0.75. This is the same thing as 2.75 hours. Everybody, do we understand that? 45 minutes, that's 3/4 of an hour. And that would be 2.75. Are we good on that? Sweet. Excellent. So now what we'll do, we'll come on over here. 2.7, excuse me there. We'll write that over here. So we'll go ahead and write this as 2.75 hours. Now we're good. We're done. We'll just write it out. Distance equals my rate times the time, just like that. So we can go ahead and write this out over here. 2.75 times 50, and we're done. 5 times 0, 0. 7 times 0, 2 times 0, next line. 5 times 5 is 25. 7 times 5 is 35, carry the 2 is 37. 2 times 5 is 10, carry the 3 is 13. So now we have 0, 5, 7, 3, and 1. How many decimal places are we moving? Everybody hit me. How many decimal places? That's going to be 2. 1, 2, 1, 2. So the final answer will be a distance of 137.5 miles. And there we go. Boom. Our answer is B. Right there. Who got it right? Who got it right?